Hi everyone, I'm Sonia Yari and I'm a postgraduate student in the School of Computing and Mathematical Sciences at AUT, and one of my papers is 3D display and spatial interaction with Dr. Barry London. In this video clip, the topic I've chosen to talk about briefly is holography and holovision. Holography is one of the autostereoscopic display technology forms that uses 3D information for computing an interference or hologram pattern and produces a 3D image. Like the other technologies in the world, it has its own advantages and disadvantages. So the main advantage has its the 3D quality of the image, which is better than the other technologies in the world. And the major disadvantages are the massive amount of data contained in the hologram, which restricts its usage to only creating static 3D images. And having images only in the limited size and restricted viewers to limited viewing angle.
Seeing a hologram for the very first time, my first visual look at what it was really a revelation that said, I think we've got something here, and I think it's something that we can take to the masses. Provision is a 3D holographic media company based here in Los Angeles, and what we do is we build 3D holograms. You know, our technology is very unique and distinct because we are truly floating images in air without the use of any kind of mist, fog. You don't need any special 3D glasses at all. And it truly is a digital image that's floating, detached from the screen that is emanating from. We're excited about working with the Kickstarter platform today because one of the things that we're looking at as the next generation 3D holographic platform is really bringing this to a full life-size image, where we've successfully developed a floating hologram from 3 inches small to perhaps 36 to 52 inches in size. We want to be able to expand that next evolution and bring a human being-sized floating hologram into the world, going to perhaps a full-size car, a full-size house. The financing and funding that we're seeking is really going to be used for the purpose of increasing the size of the optics, a new proprietary light source developed not using laser technology. We have given you the opportunity to be part of the future. We've got the patents to demonstrate we've done something very unique. We've executed in retail market channels that this is not only cool and exciting, but it's accepted. You know, from the very first hologram that we might have seen in the 60s to the movies of the 80s and the 90s, where it just gets better and better, to today, where we can actually show in real life, before your eyes and mine, the ability to see a floating image, I think continues the excitement and the opportunity for us to bring this to the world. And I think the reality is we're going to bring the holodeck experience to life. This is going to go from virtual reality to true reality in a holographic environment. I think it's going to take that evolutionary step, going from a holographic telephone to a holographic TV set to a true immersive holographic experience that you will be in charge of. You will be able to command what it is you want to do at your fingertips, at your voice. You're going to be able to command that environment. We're now asking you to be a part of our next step in the evolution of 3D holographic technology. You, by your participation in our project, are going to be able to touch and really claim to be part of something that we're creating, part of our future and part of our legacy together. Do we need this? I think we need it as well as we want it. We live in a 3D world. We talk, we act, we interact, we're immersed in a 3D world. That is what we are expecting our future to be. This Kickstarter project is going to be able to provide the conclusion, the final phase of this next step.
Electroholography is also known as computer holography. In this technique, wavelengths properties such as amplitude, wavelength or color and phase of the lights can be recorded and then reproduced to make a perfect free glasses viewing 3D images. In this technique, implementing complete digital holograms in real time, including animation and interaction, is really challenging and daunting. But there are other projects and advances that have been taken place to solve these problems. One of the projects in this matter, in this holography, is called Holovision. Holovision is a project that develops the holographic 3D displays to prevail the restrictions of the existing 3D displays. So in this method, presenting realistic 3D images to many viewers at the same time, or multiple viewers simultaneously in a wide area of view and with no common limitations. Also, this technology meets current anticipations with respect to resolution, illumination or brightness, color, contrast, and size. In the diagram shown, the light beams are generated through a light modulation system containing optical modules prepared in a particular geometry, and the holographic screen makes the essential optical transformation to comprise these light beams into a seamlessly continuous 3D image. With appropriate software control, the light beams emitting from the different voxels can be made to transmit in various directions, as if they were emitted from a common point behind the screen. Therefore, audiences will perceive the voxels or points in objects behind the screen or floating in the air in front of the screen. In contrast with stereoscopic and volumetric techniques, this technology is not associated with the negative aspects and downsides of the current 3D displays. This system reveals the main features of spatial image in the same way to holographic stereograms. As a result, removes the requirement for handling massive amount of redundant information related with only holographic systems, providing the way to technically practical solutions. The Holovision system generates all the light beams that are current in a natural 3D vision. Accordingly, we will be able to see the same as in reality. At the end, I would like to thank you for watching this video clip. Thank you.